I don't know about the relevance of this.
When we leave here, we gotta go to work.
Oops, that was me messing up here. Okay. Not used to this. You may or may not run into this, so I'm gonna go over it pretty quickly, but we've got a couple of electronic controls that are used with our ICM valve. And so typically they're gonna be used with the ICM valve for, and the AKVA pulse valve for controlling either superheat or a temperature, immediate temperature. And I mean, you guys know this stuff, so I'm not gonna, just increases efficiency of the evaporator, keeps the superheat stable, and not too low. We typically don't wanna go below 3 degrees, even with electronic control. TX3 is usually 10 and above. So we try to use electronic control for that. You don't have the high pressure differentials like you do with mechanical. It can be used to help reduce compressor discharge pressure. That translates into energy. And it typically offers faster response. So those are your advantages. So principle of operation. So we have a pressure reading with a transmitter that's sent to the controller with a 4 to 20. And the controller determines saturation temperature through the internal tables in the controller, and that's compared to a temperature that's sensed on the suction line. And then that valve setting is changed based on what that calculation is for the superheat. Put it in simple terms, they all have PID logic built into them. So here's a diagram. Evaporator, you're feeding it with an ICM with an iCAD on it, and then there's your superheat controller with your sensors. Okay. There's 2 algorithms that can be chosen. The load adaptive is the one that we typically use for industrial. There's an MSS that's used for refrigeration, commercial. But industrial, we usually use the load adaptive. Let's see, it's got alarms and relay outputs. We'll see. It has a digital input that you can start and stop regulation, and you also have an optional thermostat function on this particular controller. You'd have to have a separate, another sensor, temperature sensor, and then it would have the ability to operate a solenoid, liquid line solenoid valve. And you'll see that. So here's the basic controller. So the main connections that you need, first would be the digital input on 1 and 2. Then you connect to an ICM valve on 2 and 5, so common and 5 analog output. This is just for the basic. And then you can see down there you've got power. Or if you're using AKVA, that's on 23 and 24, so you wouldn't have the ICM. And then you've got temperature, and then you've got pressure. And those are the main things that you connect for this to make this thing work. It's parameter programmable like our iCAD, and our platforms are somewhat similar, not 100%, but it's kind of nice. So if you want to do the thermostat function, you've got to add a relay for the liquid solenoid, a relay for any alarms you want to use, and then there's your media temperature sensor for the thermostat. So you put that on the air temperature of the coil. So and then you set it in this controller. You set a thermostat set point. So I don't know, just as an example, let's say it's 30 degrees. So the solenoid's going to open when it's above that, and when it reaches 30 degrees plus or minus something, then it's going to close the solenoid and stop regulating. So it's going to maintain an air temperature with the thermostat function, what you set. Otherwise, it's just going to do superheat strictly by itself with no liquid solenoid or anything. So it's kind of a feature that you can have with this controller. The display, that's what it looks like. LEDs on the front panel are kind of mean something, and you can't well, you can see them, there's little red lights that come on there. So, you know, if the valve is opening, getting an opening signal, the little valve, there will be a red LED light. The snowflake means that that digital input is on. If that is off, then that LED is off, so it means you're not in refrigeration. And then the other indicators are simply that there's something wrong. There's lots of different alarms. There's a status alarm, there's error alarms, like error in, you know, transmitter or something, you know, you programmed your pressure transmitter range incorrectly, there, things like that. The main set point for this thing is on the front, the thermostat, like so the 30 degrees I was talking about. So here's how you're gonna set that if you're using it. So you're gonna enter it by pressing both the buttons on the front, and then you're gonna go up or down to raise or lower it, and then you press both to save it. So you can see a little commonality there. If you remember iCAD, you press and hold just the one button, and then you move around with the arrows, and then you find out what it is, and you change it, and then you press the button again to save it. This is similar. So if you do one, you can sort of figure out our stuff. We do have instructions, but I know a lot of times guys can't get access or don't have access, and they tend to figure these things out. But the key here is the thermostat setting is the two buttons on the front. So then you want to do parameters now. This is like the parameters from the iCAD. You press the top button and hold it, and you go into the parameter mode. Then you go to enter the change mode. So you access the parameter menu, and then to enter the change mode for a parameter, you have, okay, so it kind of leaves this out, but you're going to scroll to a parameter, it assumes that. And then you're going to hit both buttons, it's going to tell you what it is. And then you're going to change it with the up and down buttons, and then you're going to press them again to save it, okay? And there's a list. I'm not going to go over everything, but just to give you a little exposure to this. So you're going to just use Superheat controls, so the essential settings for any EKC 315A are right here. So we're going to just briefly talk about them here. One is the R12, that's regulation. So if that's off, this thing's not going to run. I get that call a lot actually, because it's twofold. It's digital input 1 and 2, so if that's not shorted out, it doesn't matter if you have R12 on or not. It doesn't matter if that's not shorted out, it isn't going to regulate. So the first thing is to have a switch or shorted between 1 and 2. Then when you turn R12 on, it regulates. When you turn R12 off, it doesn't regulate. The reason behind that in the software is because in the parameter list, you'll see there are some settings that you cannot change in regulation mode when this thing is running. Not all of them are, you know, it's just standard, you know, sometimes. So what you typically have to do is put it in off. So go to R12, put it off, make all your parameter changes, then go back and put R12 on. You're ready to go as long as your digital input is there. Then the units. So you have units. The default, of course, is going to be European, degree C. So you're going to want to change that to FP, which is Fahrenheit and PSI. And then you're going to want to change parameter 012 to 60 hertz, because guess what it's going to default to? 50 hertz. What else is there? Let's see, R12. Okay, then if you're going to superheat regulate, there's a couple of things you got to do, and I'm going to really glide over this. The first thing is you got to tell it what it is. Okay, so it's an ICM valve, it's an AKVA. That's pretty straightforward. That's 009. Then you enter your pressure transmitter working range. That's where a lot of people mess up. The problem is it's expecting, this thing is expecting to see gauge, okay, gauge pressure, and guess what most of our transmitters are in? Absolute. It throws people a lot. So, if it's 0 to 200 pressure transmitter absolute, when you go to put it in here, you're not going to put in 0 and 200. You're going to put in negative 14.5, and you're going to put in you're going to put in positive 180, what, 85? 185, something roughly, 180. I'm rounding it, okay? But If you don't do that, it's gonna give you an error and it won't work. And I have gotten calls on it, and the ones I like actually because it's really easy to fix it. You know, it's like, okay, you didn't set it up right, and they're always like, aha, okay, little tricks. So that's one. Refrigerant needs to be set. That's in 030. So if it's ammonia, you're gonna go in there and put that to 5. Regulation method, remember I talked about that? So, and I said that wrong. I did say that wrong. So it's called load defined control. Apologize for that. That's what we typically recommend for industrial applications. Let's see here, then the controller will regulate based on a user-defined superheat. So now you're gonna put in the maximum and the minimum range that you wanna operate in. Okay, that's gonna be some parameters. And then you verify that regulation's turned on R12. And then you're ready to go. Then if you do thermostat, you have to add, and I've already told you about some of that stuff, but there's one that you don't know. Besides the extra sensor, you gotta program, and that is you gotta set, well, you don't have to because it'll default, but there's a differential for that thermostat function, for that setting out there in front that we talked about, pushing both buttons. That's just a good thing because what that is the operating differential. So if I set 30 degrees, well, it's not gonna be exactly 30 degrees, it's gonna be 30 degrees with a differential. I mean, that's just common for control. The key one here is, okay, and I've had this happen before, actually. A guy went to all the trouble, he did everything right. He set up the thermostat function, he put in the thermostat setting, he did everything, he put the extra sensor and he programmed it, but he didn't turn on the thermostat function. That's parameter R14. If that is off, it doesn't matter what all you've connected up, whatever you've done, the solenoid's not gonna operate based on the thermostat because R14 is not turned on. It's just, I know it's crazy, but there's a reason for that, and it's imperative that you have the ability to turn that off and on. So it is what it is. So just, if you run into these, keep that in mind. Then there's also alarm parameters. They're not so important, but you just need to look at them and set them. And then again, R12 is still applicable to this. So even though R14 has to be turned on for thermostat, yeah, R12 has to be on as well for the thing to even start regulating. Okay, so you know what a pulse width valve is, okay? So it can be used in this application. We typically don't, so in a lot of applications, the pulse width doesn't work well in a plate heat exchanger, okay? So it tends to overwhelm with a lot of internal volume. So there's some places we don't recommend that. The pulse width valves typically used on the small stuff, low tonnage, and bottom line is they have to be sized based on pressure drop. ICM valve, that's not true. I mean, you want to size it generally with pressure drop, but it's not critical like it is on a pulse width valve. Let's see, what else did I forget here? Yeah. Of course, ICM, we already talked about ICM. We don't really need to. Is there anything here that's, yeah. So the rate that the valve opens and closes is determined by the settings, so we all know that. It's magnetic, la-di-da, yeah. So you can use an ICM valve, but it's the most common that I see. I run into AKVA once in a while, but ICM is pretty much what it is, even with DX, believe it or not. So here's your setup using an ICF valve station. I know I'm always blocking you, and I apologize for that. I don't mean to be. I'm not used to this.
There's nowhere else for him to sit.
Yeah. That's okay. I just wanted to say I apologize for that. So superheat control, here's some examples. So you can see the controllers lined up there, the EKC 315As. Used there with a plate heat exchanger. And you can see that's an ICM valve in that picture there. And then, see if there's, okay. And then here's the load adapt control. It's done by, it basically takes 3 points on a graph and then operates based on that curve. It works best in the particular case of industrial, just because you're wanting to adapt to the load that you've got on the system. In MSS, it's typically used in air conditioning and refrigeration, so it's just not something. And so you understand it a little better maybe, is the algorithm is always continually seeking to be the minimum superheat that's stable. So it's going to drive it down, the setting down automatically until it becomes unstable, and then it's going to bump it up a little, and then it's going to try it again, and then it's going to bump it up again, and it's going to try it again. It's just going to keep doing that. You can see that in the graph. That's not really a good control scheme for industrial applications, we find, so we don't recommend you use this. You will run into it, but we don't recommend it. Here's your air alarm and status code. So you're going to get this on the display when there's an error, and you'll see the light. Remember the lights I told you that the LEDs will come on. Those will light up, and then you'll press the bottom button, and it'll say E17. Okay, temperature sensor S3. It's got a bad connection. Or no refrigerant has been selected in the parameters, A11. So this chart and the instructions tells you everything that you need to know. I like E1, that's my favorite one. E1, errors in the controller. Don't ask me, I don't. Yeah, that's a good one. It's like, errors in the controller. Let's see, what could that be? But that's everything else that we didn't think about. Troubleshooting, yeah. So troubleshooting, you can use, remember I told you in the ICM, ICAD actuator, there's those nice service parameters, this is the same thing. So pretty handy, I've used it a lot when I can't figure something out and I want to know, well, what do I actually have? What am I getting as far as an evaporator pressure from the transmitter? Does it seem right? Does it seem realistic? Those kinds of things. And it's basic troubleshooting. These are pretty straightforward. I don't really want to spend a lot of time on them. It's valve sizing, is liquid energized, liquid solenoid, pressure transmitter wired correctly, sizing of the valve, is there flash gas, is the strainer clogged, so on and so forth. There's lots of things that can happen similar to many other systems. Okay, so the superheat controller, superheat controls superheat, and then you have a thermostat function. Here, this is a little different. This is not as common. I'll tell you where you could see this. Is you could see it you could actually see it on a compressor package. That's one example where they're using a liquid injection valve. It could be an ICM, probably is, and what you're controlling is discharge temperature, and that's all you're doing. So it's injecting liquid into the discharge of the compressor for cooling, and it's doing it based on a temperature it's reading at the discharge of the compressor. Okay, that's kind of a common one that I see, but it could be other things too. So here it's just saying, it's similar to the superheat controller, but you're not doing superheat. So you're controlling the media temperature. You can actually operate solenoids and fans. So it's got digital outputs for that. ICM is the most common used with this. Okay. And then you've got, comparison of regulators versus motorized valves. This is just so that you see. So we're talking about ICS with CVE. So in ICS and that CVE, the control is suction pressure independent, so it doesn't matter what the suction pressure is. When you're using the ICAD, ICM, the control is dependent on the suction pressure. And then in the case of the ICS, the EKC 315A, it controls the evaporator pressure based on what it's seeing as a temperature. And on the other one, the valve opening degree is based on temperature input alone. Then on ICS again, ability to limit the pressure and temperature working range of the evaporator. It gives you that ability. You're not able to do that with the ICM, okay? And then ICS, there's no indication of opening degree. And this is just talking about the reasons to use one or the other and the disadvantages and advantages. So in the ICM, we know, well, you can walk up to the ICAD and say, okay, yeah, I'm at 50%. Yeah, I'm opening. Okay. Advantages of each would be on the pressure regulator, you can control evaporator pressure to avoid freeze up, okay? In the motorized valve, it performs very well in systems with varying loads, and that's where I see it typically, not so much on the pressure regulator. And again, that one is good for systems with stable loads and varying suction pressure, because it's gonna work with that. The ICM motorized valve can operate with lower pressure drops. Yeah, that makes sense. A pressure regulator can't, and it works well at low loads, because of the range that the ICM valve can handle. And wiring, we kind of glazed over that, but here you go. So the important stuff you can see there is the digital input. Depending on the valve, you're gonna either have it up there on 2 and 5, or you're gonna be down here on the AKBA input, or you could actually be controlling the old valve, but I don't talk about that because it's gone. What I talk about is the CVE. So the CVE, that big pilot with the motor actuator, it's real simple, because now you're just operating this controller with almost an ICM valve, but it's an ICM pilot, this regulator. So it's very much the same. You've got 2 temperature inputs. A lot of times this confuses people. You remember on the Superheat controller, we had the option for another one. We had temperature on the suction. And then we had auxiliary for the thermostat function. Here you've got, it's a little confusing. Here you don't have the pressure, but you've got an air sensor, and that's straightforward. That's the air temperature. So what is the aux? Well, the auxiliary is just a nice temperature that is added, but it's only displayed. So you could, let's say there's a temperature you're interested in, okay, but it's not doing anything, it's just displaying. You could wire that up, and then you press the bottom button during operation, and it shows you that temperature. Okay, so it's just a nice little feature to have. Let's see here, and these are the parameters when running an ICAD with the EKC 315 media temperature. So it's very similar. The one that's important is that first one, NO3. That selects what it is. So if it's an ICM, it's going to be 6. If it's a CVE pilot, okay, it's going to be a 6, because remember, that's an ICAD. It's like it's an ICM valve. So the other choices are AKBA and the old CDQ, which is gone. It's been discontinued. It was replaced by the CVE pilot. Okay. So 60 hertz, very similar to the Superheat. Parameter NO7. So you've got to select control, PID control. Okay, so that one takes, it depends on what you want. So do you want it to drive to the set point slowly? Do you want a bunch of underswing, or you just want mild underswing? So there's 3 choices. And that's part of the PID. And then you have optional alarm parameters. Okay, so with that, just here at the bottom, and it makes sense to you probably, the fastest possible cooling is a setting 1. Okay, that's going to be the middle one. The one with less underswing, that's going to be the 0, and where underswing is unwanted, that's setting number 2. So that's down here. So you just drive right to the point, but slow. You don't get there fast. You better be patient.